a hypothesis test. Okay, this is a different, it's still a memory training scenario, but it's not what we just saw. It's a little different. Okay, so let's pick it apart a little bit. All right. Suppose 32 seniors were randomly selected to try both memory strategies. Each student calculated the difference in the number of words, strategy 2 minus 1. The mean of the differences, so these numbers are different than what we just used. The mean of the differences is 1.5, standard deviation is 2.7. Do these data give convincing evidence that strategy 2 improves memory at alpha of 0.5? Okay, so very similar start, right? Very similar. We have to define the parameter. Mu of the differences. True mean difference in remembered words. So I do strategy 2 minus strategy 1. All right. Statistic, I'm just going to write what it gave me in the question. X bar was 1.5 and the S of the differences is 2.7. All right, hypothesis. Let's think about this for a moment. We would use mu of the diff. You can just use mu d. D is fine as well. What is the null going to be? 0, because it means no difference, right? No change. So the difference would be 0. Now, you got to stop and use your thinker on the alternative. Which way should our inequality go here? It says, does it give us evidence that strategy 2 improves memory? What would that tell us the difference would be? Greater than 0. Are we okay with that? All right. Significance level given as 0.05. All right. Name the procedure. All right. Nothing new. We know we're doing matched pair, so we would do a one sample t-test for matched pair. Or if you didn't want to say matched pair, you could say mu diff. That's fine too. Either one is okay. Now, let's think about the scenario. Is this an experiment? No. How do you know?
They didn't randomly select which teacher was to which first.
Yeah, there was no random assignment in this, was there?
They were just randomly chosen.
They were just randomly chosen, so that's more of a sampling, right?
Yeah.
Yeah. It's like splitting hairs, isn't it? It's like there's no random assignment of which strategy they started with. And it just says randomly selected seniors. So that's like a random sample of seniors, right? So in my mind, I'm going to connect that with sampling. So when I do random, I'm going to treat it like a sample. It says there's 32 randomly selected seniors. Okay. Now, do you remember before we said random assignment allows us to conclude cause and effect? We can't conclude cause and effect with this test because there was no random assignment. But what we can do when it's a random sample, do you remember what the purpose of random sampling is?
Apply the conclusion to the population.
Good, yes, very. We can generalize to the whole population. You can't necessarily do that with an experiment, but a truly random sample, you can. Okay? It's one of those little special things they like to ask in multiple choice. All right, so then would I need to check 10%? Yeah, it's not an experiment, so yeah, I would have to. So sampling. So 10% rule. So is 32 less than 10% of all seniors? I think that's a safe bet. Yes. And then what? Large count or normal? How do we check that with this one? Will CLT work for us? Yes, it will. 32 is greater than or equal to 30. So by the CLT, we're good. All right. I don't care about formula. I don't care about formula. I do want you to draw me pictures, though. Nice and neat, please. What kind of test is this? Left-tailed, right-tailed, or two? Right-tailed. Okay, so let's make a prediction. There's going to be a t value right here, right? Is it going to be positive or negative? It should be positive. Okay, good. So what am I writing for my work? I'm going to write out what is the difference I'm inputting in my calculator. It was 2.07. The S, 2.51. The sample size was 32. And degrees of freedom would be then what? 31. All right, in my calculator, I'm just going to use t-test. I think it's number 2. Yeah. So it's number 2, t-test. And let's put this in. What did I do? What'd y'all get for T? 3.14? Mm-hmm. Makes sense. It's positive, right? P-value? O2? O2? Okay. O2. Oh, that's my problem here. I see it now. Still not right. Okay. Oh, I got that. All right, now, conclusion. Do we have what we need to make a conclusion? Yes, okay. Connect it. So since 0.002 less than 0.05, what are we going to do with that? We reject the null. Then what? We have convincing evidence that I can go back and state it like I did the true mean difference of the range strategy, or I can just make it make sense like this. We have evidence that strategy 2 improves the memory. Doesn't that mean the same thing? As long as it's in context, it's fine. As long as you don't accept the null in your language, you're okay. Okay, don't say we have evidence that strategy 2 is, or strategy 1 is bad. No, we don't. We just have evidence strategy 2 is good. Helpful. Okie dokie. Now, let's just say one sample test. It's not a big deal. What again makes this more challenging is just identifying when you're reading these long problem stems, identifying am I doing a two sample test or a one matched pair test. So that's what we're going to get on the back page here. At the top, it's just summary of what we've talked about. So paired T is one sample. So one thing I sometimes helps if you think it's 2 sets of data from 1 unit. Okay, 1 experimental unit. Could be a person, it could be a plot of land, it could be a container, but 2 sets of data are taken from the 1 unit, right? And then 2 sample T are 2 independent samples, completely separate samples. Some language that you sometimes see, and it, just hold on for the ride here. Matched pair is the mean of the differences. two sample is the difference of the means. See how similar that is? It's very confusing, isn't it? Mean of the differences means you subtract first and then you treat it as one. Difference of the means is completely different. All right? Now, what we're going to do on this last portion here is just read the scenario and decide which one is it. Is it paired or is it a two sample? And you'll begin to see what you're looking for, okay? So look at number 1. A random sample of 30 adults were selected. Each adult reported the number of pieces of junk mail they received in their mailbox at home that day, as well as the number of junk emails they received in their inbox that day. Researcher would like to know if adults received significantly more junk email than junk mail in their mailbox. What do you think here? Paired. Why do you think it's paired?
Because it's the same pattern, only two different things. It's not two different groups.
Two pieces of data traced to the same individual, right? So maybe it helps you to do this. One person is giving two things: number of junk paper mail, and they're reporting the number of junk emails, right? But they are traced back to a single person. So that is my indicator, then this would be a matched pair. Okie dokie. Miley, look alive. Wake up. Number 2. Random sample of 100 people who live on the West Coast and 100 people who live on the East Coast are selected. Each person reports how many spam calls they receive in 1 week time period. They'd like to know if the people who live on the West Coast receive significantly more spam calls than those who are on the East. What do you think? How do you know? You are correct. Why is it too simple?
Two groups giving the same input.
Two completely separate groups of people, right? East Coast, West Coast. So this is a two sample. So there's 100 on the East Coast, 100 on the West Coast. This two independent samples, they would say, right? All right, look at number 3. Researcher randomly selects a variety of 15 cell phones from different manufacturers and different providers. Researcher measures the signal strength from 2 different remote areas, one in the state of Pennsylvania, one in the state of Virginia. Researcher would like to know if the signal strength is significantly weaker in the remote area of Virginia.
I think it's matched pair,
Why do you think it's matched pair?
because, one cell phone is providing data for service strength for Pennsylvania and Virginia, and so it's like a. so you get
They're
two
testing each phone in both locations. Do you see it? So each phone is going to give a signal strength from Pennsylvania and give a signal strength from Virginia. They're wondering if Virginia is stronger. Okay? Now,